How is it going? In this video, I want to try and explain sprite groups, collisions, and drawings and stuff like that. So let's get started with this. So I have a script here, and here's the demonstration. So right now, we would be calling for sprite in sprite list, and right now its length is 0. And I drew a grid on the screen so you can see the positions and things like that. So if I press space, we have created a sprite of these dimensions, and it shows at the top here. This is the sprite list. This is the list of sprites. And if we keep pressing space, we're going to show that every index is keeping track of its information. So here we are, we have speed of 159, which is represented in the middle here, width of 70, height of 68. And so the top left corner is the rectangle's top left corner. And I can supply this in my GitHub. I'll put a link in the description. And so you can explore this, but we're going to go through what this actually does. And so if we keep pressing space, we keep adding elements, and we see that for each sprite in sprite list, we are drawing and updating these. We're also checking to see if they collide or not. Okay, this one looks like, so these collide with that one, then this one's also colliding. And then once it gets beyond all those, they all stop colliding. Once the left side reaches the width of the screen, then they're gone. So let me show you how this all works. The first thing I did was import the Pygame library, and then I imported random, and then I imported the time module. And for delta time, I'm using the time module as opposed to using pygame.time.getText. Because when using time, the time scale in which it lies within means that I can use speeds which are positive integers, as opposed to using decimals, which are less than 1. We initialize Pygame. We get the width and the height for the screen. And then we create the screen using the dimensions of the width and height. And then we set up a clock so that we can use that in the game loop that we can use for governing the frame rate. And then I created some font elements. So I gave it a title font, a small font, and a sprite font. And those are all represented. These are the title fonts here. These are the small fonts, and these are the sprite fonts. And so I set them up, and then I initialized last delta to the current time. To make my life a little easier, I made a function, and we called it right. And so we want to set the surface that it goes to. I called it screen. I should probably have called it surface. The font object, which will be this. So whether we're using the title font, small font, or sprite font. The text, which is going to be a string that we put into it. And then its position, which is going to be a tuple of 2 coordinates, an x and a y, and a color. And the color is going to be a string, or it's going to be a tuple of 3 elements, because this color can accept either a string with a color name, or it can accept a tuple of red, green, and blue values. So this function has the first element, which is what I call render, and that is taking the text that we supply it and turning it into a graphic. So our font render. So remember, this font object is going to be this. So if we wanted it as a title, we would put title font dot render, and then the arguments for that are the text we want to supply it. This is whether it's anti-aliased or not, and this will be the color. Like I said, it's either going to be a string with a color name, or it's going to be a tuple of 3 elements for red, green, and blue. Then we are going to create a rectangle, and we are going to take the render of the text and get the rectangle elements from it. And that's going to be a 4 element list of an x and a y coordinate, and then a width and a height. And so what we're going to do is we're going to take the position which is an X and a Y coordinate. That's a tuple with an X and a Y. And then we're going to set that as the center position. And what that does is it takes the X and Y coordinate and the length and the width, and it will offset, drawing it. So we say we want this at the position of, say, 100 by 100. And then if the text graphic was also a 100 by 100 square, then the rectangle will have the X and the Y coordinates of 50 by 50, because that would be the offset from the center of the rectangle. So the last thing we do is we take the screen, which we will supply this screen surface to it, and we will blit the whatever we have as the renderer at the position of the rectangle. And Pygame typically draws everything from the coordinates of the top left corner of the surface. But to make things easier, like I explained a little earlier, the position will offset that top left corner by referencing everything relative to the center. And that would also give us options to be able to supply like the rectangle's top left or top right or left, or so, you know, depending on what you're doing. If it's just the X coordinate that's important to you, then you can just reference the left, which we do later in the class, which we get to now. So the class, we supply it a position, a size, and a speed. And the position is going to be a tuple. And that's going to be, the first element is going to be put into self.x, and the second is self.y, which is the X and Y coordinates. The size is going to be the size in the X direction and the size in the Y direction. So given the X and the Y coordinates and the length and the height, we're going to get ourselves a rectangle. We can see here. See, there's the top left, the rectangle's top left position. Do another one. And see, the width is 125. So this length is 125, and this is 67. And so when it goes to draw this, it starts with the top left, and then it draws a line and another line and a complete rectangle. And so this is where we make the image. So this could be an image that you give it, and that would supply the rectangle dimensions. But in this case, I just wanted to create an invisible surface, Pygame surface. And then I gave it a single element, which is a tuple. This is why there's like double brackets, because you can't do this. And so the size, if we were to put that comma in there, is going to be expecting like flags and other stuff that we don't really need to give it. All we want to do is create a coordinate system for it to draw at. So that's why we had the single tuple of its length and height. So size X, size Y. Then we're going to take that image, and we're just like the text, we're going to get the rectangle, and then we are going to say the position of X and Y that we give it. We're going to say that is the center of it. So offset the rectangle's X and Y by the half of its width and the half of its height, which was going to put, you know, if we, again, like I said, if we put self X and Y at 100 and the rectangle was 100 by 100, then the top left coordinates would be 50 by 50, because that would be, the center point would be the halfway distance between the width and the height, and half of 100 is 50. Speed is just a straightforward, we're going to take the speed and we're going to pass that into the instanced copy of this class as speed. So they have the same name. We could change this. to SPD. Then we'd have to change this to SPD, and that will get the same effect. And then we can notice that this speed is different from this speed. Now, here I create a list of colors to be used. So this is just a list of strings that have color names in them, and those can be supplied to the rectangle self. I'll get to that. And so the self.color will be a random number between 0 and 6. And so this is 0, 1, 2, 3, 4, 5, 6. So this generates a random number between red and violet, and then stores that here. And then this is just a hitbox that's been initialized to zeros. I do that because just for explanation purposes. The hitbox is essentially going to have the same information as the rectangle. And so you could just use rectangle if you want. But as we see when I get down into the collisions, it makes more sense if I say source sprite.collide target sprite hitbox. I could say rectangle there, be the same thing. And so that is what everything's going to be initialized as. So if we go down to this spawn section, this is how I add the elements to the sprite list. So whenever we press space, we go down here and we go to handle events, and we go down to key down, and we go down to space, we go directly into the class. This is the actual class. This is not an instance of it. This is the actual class. And we are calling the spawn method, and we are giving it a sprite list. So sprite list is the name of the list of all the sprites. And so when we execute this, we set a position, and we generate a random number between, well, actually we don't. This is the x coordinate, which is basically -32. So I want it to start off screen. In fact, if my rectangles are bigger than 32, we're still going to see them. So let's do -100. And that's the first element. That's the x coordinate. And then, again, this is a tuple. Then we have a random number between half of the height of the screen and the height -32. So we really want to do height -100. That way they remain on the screen. Then the size, well, there's the size 128. So that would have to be 128. That way none of them go off the screen, and these will always start off screen. All right, the size on the x coordinate, this is a tuple that has two elements separated by the comma there. The random integer between 64 and 128, and then another random integer, which is a different random integer between 64 and 128. And this is going to be the x and the width and the height. Then the speed is just going to be an integer between 100 and 200. And then the group that we supplied it, like I said, sprite list. So when we call the spawn method and we give it the sprite list, which is the sprite list here, then that is going to be our group. And so our group in this case is going to be sprite list. And so sprite list append means that we are adding an element into the sprite list. And what we are adding is an instance of the class random sprite. And we supply its position, size, and speed. Yeah, right here. The position, the size, and the speed are these elements that we throw into it. So then this gets added to the group, which we saw here. So if I press space, this is the sprite list, the contents of the sprite list, and there we are. We've added it in there. It's at the 0 index. This one has a speed of 129. It has these dimensions for the surface, and the rectangle has been updated in 420. Anyway, there's another one. So again, and if we keep pressing space, it's adding another one. And so it will iterate over these and keep updating them from the instructions. So that is what we're going to talk about next. So let's get down here. So here we are in the game loop. These are the events. We don't need to look at those. This is delta time, but I'm using time here. Let's look at the update. So what we're doing here is we're saying take the sprite list, and for each item in there, we're going to store that as sprite for reference later. And we reference that, in fact, right here. Most loops have things on separate lines like this. So you would have like, everything that's happening in this loop would happen here, but we only have one thing. So I like to keep it on the same line. So that first element, so we press space and we create the 0 index. And so it iterates through the list and it finds the 0 index and calls it sprite for this moment. So we say, okay, so for that sprite, which is a copy of the class here, we want to say run the method update, and we supply the argument sprite list. So then that 0 index of the sprite list then goes into update with the argument sprite list, which will be in group, because self is the name of the instance of the class. So group then carries with it sprite list. So then we say self.rect, so we update the X and the Y position, and we make it a part of the rectangle, the self.rect thing. And then we make the hitbox have the same information. And then we take the X coordinate and we take the speed, multiply it by delta time so that it's not like super fast. Because delta time, again, if you want to get an explanation of what delta time does, check my other video. But delta time will adjust the speed so that if the frame rate is faster or slower, then speed will get bigger and smaller. So it doesn't move faster across the screen. It cancels out. So X will then plus equals, which is the same as self X equals self X plus something else. So it will basically update self X to keep increasing in value, which means the way we're using it is it's the X coordinate across the screen. And that's what you see here. This is the X increasing in size. So, and remember, that's our frame rate at the top. And just as a demonstration, if we change that to, say, 60 frames per second and run this again, it's still going to go across the screen at about the same rate, but we're at a lower frame rate. That's because speed has been increased in size so that even though we're running less frames every second, the jump between frames increases so that it maintains the same speed as it would anyway. So let's take that back to 0. Then we get down to the good section. So here we are in draw, and the first thing we do is we wipe the screen black. If we don't do that, this happens. So everything looks fine so far. Then we do this and see, look, everything that's a graphic is getting updated. The grid is being drawn over again, and yeah. So if we did this, we just basically get a rainbow. This is what happens when you don't blank the screen out. So we blank the screen out. We basically fill the screen with black. This is the logic for drawing the grid. If the height is a multiple of 400, which means there is no remainder, then draw a line and make it this color, which is basically gray, but a dark gray. So if that gets satisfied first, it will draw this. Then if it doesn't get satisfied, then the next thing we do is we want to see if it's a multiple of 100, and then do the same thing with a different color, which is a darker color. And then finally, we want to make the really, really tiny lines. So if it's a multiple of 10, then do that. And we do that for both the X and the Y. And that's just to make the grid. Now we go down here, we have again for sprite in sprite list, then we set text, and this is drawing the text that shows in the sprite list. So it's the same thing here. So the index is the sprite list index of the sprite. The speed is the string value, so it converts this number into a string. If you want me to explain that in a future video, I can. String of the sprite image, so that shows us the surface. And then finally, the rectangle dimensions. And that's what we're doing. So we have the index, then we have the speed, and then we have the surface dimensions, which were randomly generated. And then the rectangle, and it's only moving on the x-coordinate, so the x-coordinate is increasing in size based on delta time. And the length, you can do len sprite list, and it will pump out a number, and that's what this number is. For sprite in sprite list, we are drawing it. So for each element in sprite list, each index, so again with the 0 index, we copy all that information into sprite. So the instance of sprite in the list at the 0th index gets copied as a sprite here. And then we say, okay, from that sprite object, run draw. And draw will do all these things. It will take the surface, because we supplied a surface. Screen is the surface. Remember, screen is this object here. So we define the screen with the width and the height. So we say, okay, we want to draw it to that thing. And so we come back up here. So we surface blit, which is a method of drawing the self image, which is from that 0th index of sprite list, whatever stored as self.image, which is this surface here with these dimensions, then that will be drawn at the rectangle that we figured out here. And remember, I said the center offsets these two coordinates. So if the rectangle dimensions were 80 by 80, then this would be 40. So it's always going to be half. The x and y coordinates of self.rect are always going to be half of the width and the height. And so we draw that there, and then we draw a rectangle around it. So Pygame draw rectangle. This is what actually makes the colored rectangle around the surface. So we draw that to the screen. We say we want to draw a rectangle to the screen. So we generate a random number between 0 and 6, say 5. And then we go into the list of colors and we say, okay, what is the index 5? 0, 1, 2, 3, 4, 5. That's indigo. So the color that we say is indigo, and it would be this string in the quotations. So we want to draw a rectangle. And let me do this to bring up there. So the rectangle is going to be the surface, and then the color and the color value. And the color value, like I said, is going to be indigo, or it could be a tuple of 3 elements for the red, green, and blue. Then we move over to the self.rectangle, which is the 4 elements. So the x coordinate, the y coordinate, the width, and the height. So that is essentially drawing the rectangle. And then finally, the width. So I said it has a width of 2. Let's set that to 10. And so now we've got a nice thick border. So let's set that back to 2. And then the rest of these, now remember this function that we wrote earlier where we write to the screen, pick a font, write some text, position it, and then give it a color. This is what we do here. So we write it to the surface, we use the sprite font, and we take the string of the speed. So we take the speed value, and then we convert it into a string so that we can send it through the write renderer. So the write renderer. So when we do a text object, it expects a text object. It doesn't expect a value, an integer or a float or anything. So that is why we run it through string. So we convert the self.speed to a string, and then we position that in white using the self.rect, and then we pass it a sub parameter called center. So we want this to be drawn in the center. And so what we did here is we also made the position the center of this. So the center of the rectangle that draws the writing is going to be placed in the center of the rectangle that is the surface, the sprite object. So therefore, this speed is exactly in the center of here. And then we do the same thing with the other writing. So this top left, we set the self rectangle at the top left position, and we only want the X element because we want to offset just the X element by 30. And then we do the same thing again. This is a tuple of two elements, which is the X and the Y coordinates. But the reason we took the top left point and pulled out the first element of it, because self.rect top left is also a tuple of two elements, but we only want the first one and we want to offset that by 30. Then we want to grab the second one of the top left element, which is the first index, and then we want to offset that by 50. And what that does is it gives us this position here. And then we do the same thing underneath it, except in this case we just do we display the top left coordinates. So that's what we're seeing here. So when we offset it by 30 and 50, we took this point here, and then we went up by 50 and left by 30. And so this part here is going to be updating the coordinates. And then we have the width and the height. And so here we have a string, and then we added, which when you use the plus with string elements, they concatenate. So W plus then the string of size of X, the self.size of X. And so that brings us to this width. So this is the size of X. This is the size in the X direction, which is 70 pixels. This one's 79 pixels. And then the same thing for the height. Now, finally, we're getting towards the end. We have the collide. So first, let's go down here into the draw section, and then here's where we deal with collisions. This is a little tricky. So instead of saying for sprite in sprite list, we now have to distinguish between two different things because we are getting everything in sprite list to collide with itself. Now, if the item at the 0th index was allowed to test whether it's colliding with itself, it will always be true. And therefore, every element would be colliding with itself. So we need to distinguish between the two. So first we need to check every sprite in sprite list. Say we got two elements, right? We have we're the 0th element. And now we want we want to do it again. So we want to go in sprite list again and check all elements. So we're at the 0th element. And now if the source sprite doesn't equal the target sprite. So in this case, it does. Source sprite is at the 0th element, and it is identical to the target sprite at the 0th element because they're both pulling from the same sprite list. So this would be false because those are identical. And for this to be true, it has to be different. So then it moves on to the first element. So the source sprite is still 0th, but the target sprite is now 1. So if those are different, and they are, if source sprite dot collide, which is this method, and we supply it, okay, source sprite dot collide, and we give it target sprite's hitbox. So remember up here when I set the hitbox to that, and then I said the rectangle becomes hitbox. Well, it doesn't become, it gets copied into hitbox. So it has all the same information, which is the X and the Y coordinate and the width and the height. Well, now we need to check that. So if source sprite dot collide target sprite hitbox. So now let's go up here to collide. So we have rectangle, which will be the target sprite's hitbox. Here we define a few things. So this is the target. If the left side of the target, well, okay, rect left is the left side of the target. Rect top is the top side of the target. Rect right is the left side plus the length of in the X direction, and the bottom is the Y plus the height in the Y direction. So we have defined the 4 faces, and the same thing with the hitbox for the current object. So this is the source. This is the target. This is the source. So we have set, those are what those are. Now here is the logic. So if the right side of the target is greater than the left side of the source, and the left side of the target is less than, which means it is left side of the screen, than the source's right side, then that is a collision in the X direction. But it doesn't necessarily mean it's a collision, because it could be way too high or way too low. So now we're going to test that out. So if the target's bottom is further down the screen than the top part of the source, and the top part of the target is less than, which means higher than the bottom, then if those 2 conditions are met, then it will return true. There is a collision. Otherwise, false. And we can see that. So if we keep hitting this, see, look, this, the top half is between this and this, which means it's a collision. And when this lets go, we see that the right-hand side is not higher than the left side, but also the left side is not greater than its right side. And that is what the logic is doing there. That might not have made sense, but yeah, that is that. So this is essentially how we do it. So this is just, for the drawing of the sprite. And then this is just text on the screen, This is this text here. That, and that. And then the collisions are, if you weren't doing the collisions with the same group, like if you had 2 different things, you wouldn't have to check to see if the source sprite is different from the target sprite. I only did that because we were pulling from the same sprite list. If you're pulling from different lists, say you had your player was firing multiple bullets, your bullets would have their own group, enemies would have their own group, and you would fire lots of bullets. And then for each bullet, we would check to see the bullet in the 0th index touched each enemy. And then if it did, we would check to see if there's a collision. And then if there is a collision, then we would do something. Like instead of just saying collide, we could make it destroy. Like we could pop them. So instead of collide, we would do sprite list dot pop, which means to remove an item from there. And then we would want to list dot index of source sprite. And so if we do that and they collide, they should both disappear. And okay, that one went. And this one remained. So if we wanted to pop both of them, we would basically do this. Target sprite. Those are going to disappear. Oh, those touched first. All right. They're all touching. And there you go. So I think this has gone on long enough. So I hope you learned something.